Hello everyone, welcome to today's class. We have this radical equation before us here. The question is k equal to the cube root of k to the power of 3 minus 3k to the power of 2 plus 1. What is the value of k that will satisfy this equation? This is a very simple equation, right? So first here, let's take our solution. All right. Now, the first thing we're going to do here, we have a cube root radical here. We want to move this quantity that is attached to it to this side of the equation. So doing that, this is going to give us our k, right, minus your 1 minus 1 is equal to the cube root of our k to the power of 3, then minus 3k to the power of 2. Easy. Right. Okay. Now we want to eliminate this radical here now. And in eliminating this radical, we have to take the cube of both sides of the equation. Okay, so we're going to take this, raise it to the power of 3. Then we take this, raise it to the power of 3 also. So this power 3 takes care of this cube radical. Then we have to open up this expression we have here. We can either use the binomial expansion to open up this. And if we use the binomial expansion to open up this is going to give us our k raised to the power of 3 minus our 3k raised to the power of 2 there plus our 3k there minus our 1, right? Everything will now be equal to our k raised to the power of 3, then minus 3k raised to the power of 2. Wow, this is pretty easy, right? Good. So we can check out the things that are existing both on the left and the right hand side of the equation. Here we are having k to the power of 3. Here we are having k to the power of 3. And here we have positive, positive. So if we collect like terms, what happened? This and this will leave. Wonderful. And here we are having minus 3k to the power of 2. Here we are having minus 3k to the power of 2. So what happened? This and this will also leave the system. Wow. So we are just left with our 3k minus 1 is equal to, on this other side, we're left with just 0. So what we do, move this quantity to this side of the equation. So this gives us 3k is equal to positive 1. Since we are looking for k, we just have to divide by 3. So we divide through by 3, we divide through by 3. So what happened? This and this leaves the system. So we're having k is equal to 1 all over 3. This is the one root that satisfies this radical equation. But here, can we prove if this actually satisfies the original equation? Look at the original equation here. So we want to put in the value, our k equal to 1 all over 3 into anywhere we see our k. So here we have here check. So let's take our check. So check. So we have the equation k is equal to our cube root of our of our k raised to power 3 minus 3k raised to the power of 2, then plus our 1, right? Good. So from here, we have k to be 1 all over 3. So we have 1 all over 3 is equals to, we have here the cube root here of our 1 all over 3 all raised to the power of 3, then minus here our 3 into 1 all over 3 all raised to the power of 2, right? Then plus our 1. So this expression is going to give us the cube root. So you have cube root of 1 all over 27, right? Then we minus our 3 into our 1 all over, this is times please, 1 all over our 9. Then everything plus our 1 here. All right. Then from here, we can multiply out. So this is going to give us our cube root of our 1 all over 27, then minus, we use 3 here, 1, 3 here will give us 3, so we are left with 1 all over 3 plus our 1. So from here, mind you, on this side we have our 1 all over 3 is equal to the cube root of our expression we have here. So we can find the LCM of everything here. So the LCM is going to give us our 27, right? Good. So 27 to 27 will give us our 1. 1 times 1 will give us 1. Then minus 3 to 27 will give us 9. 9 times 1 will give us 9. So we have here 9 here plus our 1. Plus our 1 outside here, right? Good. So let's continue here. So this is going to give us our cube root of our minus 8 all over 27 plus our 1. Wow. So what is the cube root of our minus 20 minus 8 all over 27? This will give us our minus 2 all over 3. There plus our 1. Okay, this is all over a visible 1. So if we find the LCM of everything, this is going to give us our 3. Then 3 to 3 will give us 1. 1 times minus 2 will give us our minus 2 plus 1 into 3 will give us 3. 3 times 1 will give us 3. So we now have a minus 2 plus 3. And minus 2 plus 3 will give us our plus 1 all over 3. Mind you, on this other side, here we have our 1 all over 3. So it does means that our 1 all over 3 is equal to 1 all over 3, which shows that the answer which is solved for here satisfies the original equation. K equals 1 all over 3 satisfies the original equation. So this brings us to the end of this math class. If you have any question with regards to this problem, drop it in the comment section and we'll answer you there. Thank you for being there. See you in our next class. Till then, keep winning.